Good morning all. Today we are going to discuss about thermocouple. So one of the most common used method for the measurement of moderately high temperature is we use that the thermocouple effect. So when a pair of wires made up of different metals is joined together at one end and the temperature difference between the two ends of the wire can produce a voltage between the two wires. So this is the basics of thermocouple. So we can look into it detail. The temperature measurement with thermocouple is based on feedback effect. Feedback effect. A current will circulate around the loop made of two dissimilar metals when the two junctions are at different temperatures as shown in the figure below. When this circuit is opened, a voltage appears that is proportional to the observed Seebeck current. There are four voltage sources. Their sum is observed as the Seebeck voltage. Each junction acts as a voltage source and is known as Peltier EMF. Furthermore, each homogeneous conductor has a self-induced voltage that is known as the Thomson EMF. The Thomson and Peltier EMFs originate from the fact that within the conductors, we know that the density of the free charge carriers, that is the electrons and holes, increases as the temperature increases. If the temperature of the one end of the conductor is raised above that of the other end and the excess electrons from the hot end will diffuse to the cold end. This gives an induced voltage and this process is known as Thomson effect. This results that the hot end is positive with respect to the cold end. Now, conductors made up of different materials have different free carriers densities even at the same temperature. So, when two dissimilar conductors are joined together, electrons will diffuse across the junction from the conductor with higher electron density. So, when this happens, the conductor losing electrons acquire a positive voltage with respect to the other conductor. So, this induced voltage or this obtained voltage is known as Peltier EMF. So, coming back to the procedure, when the junction is heated, a voltage can be generated. So, as I have already said, this is known as the Seebeck effect. The Seebeck voltage is linearly proportional for small changes in temperature. So, this is the basic of thermocouple and the various combinations of metals can produce different types of thermocouples. The magnitude of this voltage depends upon the material used for the wires and the amount of temperature difference between the joined ends and the other ends. So these are the depending factors and the junction of the wires of the thermocouple is known as a sensing junction. The junction between the attached wires is called a sensing junction and this junction is normally placed in the unit under test. So, since it is the temperature difference between sensing junction and the other ends that is a critical factor, the other ends are either kept at constant reference temperature or in case of very low cost equipment at room temperature. In the latter case, the room temperature is monitored and the thermocouple output voltage readings are corrected for any changes in it. Next, because of the temperature at this end of the thermocouple wire is a reference temperature, this function is known as reference and also the cold junction. So, a thermocouple therefore consists of a pair of dissimilar metal wires joined together at one end, which is a sensing or hot junction, and terminalized at the other end, which is a reference or cold junction. So this is maintained at a constant temperature, which is the reference temperature. So when a temperature difference exists between the sensing junction and the reference junction, an EMF is produced. This causes the current in the circuit. So when the reference end is terminated by a meter or a recording device, the meter indication will be proportional to the temperature difference between the hot and the reference junction. The magnitude of the thermal EMF depends on the wire materials used and the temperature difference between the junction. So, a thermocouple may be regulated as a thermometer based on thermo EMF and works on the principle that the potential difference between two dissimilar metals or metal alloys in a function of temperature. So, actually there are three types of thermocouples known, which is type E, type S and type T. So type E is the thermocouple units use chromal alloys as the positive electrode and constantan alloy as the negative electrode. For type S, we have which is a thermocouple which produces least output voltage and can be used in a wide variety of temperature range. So this is the graph which has the thermocouple output voltage as a function of temperature for various thermocouple materials. In this graph, the copper which is used as an element and constantan used as an alloy of nickel and copper. The copper side is found to be positive and the constantan side is negative. So let us assume that the copper wires that is used to connect thermocouple to the next stage, that is a circuit, a second copper constantan junction which is produced. This junction is called as the reference junction. So it generates a Seebeck voltage that opposes the voltage generated by the sensing junction. So if both the junctions are at the same temperature and the output voltage, that is V out, will be 0. And if the sensing junction is at the higher temperature, V out will be proportional to the difference between two junction temperatures. The temperature cannot be derived directly from the output voltage alone. So it is subjected to an error caused by the voltage produced by the reference junction. So this can only be overcome by replacing the reference junction in an ice bath at a particular temperature, and this process is known as the cold junction compensation. The reference voltage which is maintained at 0 degrees Celsius. So the reference voltage is now predictable from the calibration curve of the type T thermocouple as shown in the figure earlier. So when a copper is not one of the thermocouple metal, then 4 junction circuit is formed. The type J thermocouple uses iron and constantan as the two elements shown in the figure. When it is connected to copper wires, two iron copper junction result. These junctions present no additional difficulties because of the isothermal block used. The block is made up of material that is poor conductor of electricity but a good conductor of heat. Both iron copper junctions will be at the same temperature and generate the same Seebeck voltage, and hence these two voltages will get cancelled. So the cold junction compensation is also used as a reference junction in this case, that is for the type J thermocouple. The ice bath method is not actually the most convenient method to do in a commercial setup. So this technique is often used in the calibration laboratory, and the industry actually uses a different method for the reference junction compensation. So, industries use electronic ice point reference. So, the isothermal block contain two reference junction and a thermistor. The resistance of the thermistor is the function of a temperature. A circuit is used to sense this resistance and to compensate for the voltage introduced by the two reference junctions. So, this arrangement is known as electronic ice point reference. If the sensor is interfaced to a computer, the reference temperature will be converted to as a reference voltage and then subtracted from the output voltage Vout, and this is known as the software compensation. An isothermal block with one temperature sensor can provide compensation for several units. For accurate measurement of hot junction temperature, cold junction or the reference junction should be kept at 0 degrees Celsius. If the reference junction is kept at the ambient temperature, then a voltage corresponding to this temperature must be added to the measurement to obtain accurate reading. So, most common thermocouple measurement system employ electrical cold junction compensation. A popular technique used for the reference junction compensation is used in the data loggers and data acquisition system shown in the figure. The measuring junction's terminals are screwed on an isothermal block and the temperature of the isothermal block is measured independently and compensating voltage generated using an electronic circuitry. The compensation voltage is combined with the EMF from measuring junction to obtain the true temperature. Thermocouples are sometimes connected in series or parallel to provide increased voltage or current output. In the first figure, four thermocouples are actually connected in series and the wire A is positive and the wire B is negative in each thermocouple. So, the total EMF between points 1 to 5 is the sum of individual thermocouple EMF. An arrangement of this type is called thermopile and is used to obtain increased sensitivity and greater absolute EMF from thermocouple installation. So, the second figure shows four thermocouple which is connected in parallel method. This arrange provides a large current but EMF is same as that of any one thermocouple. So the thermocouples must be protected from mechanical damage and isolated from corrosive or contaminating effect that most gases and liquids have at high temperature. The device used for this purpose are called wells or tubes depending upon their physical construction or thermo wells. Now let's discuss about the advantages and disadvantages of thermocouple. So talking about the advantages, actually it has a rugged construction and temperature range usually varies from minus 270 degree to 2700 degrees Celsius. So the usage of extension leads and compensating cables, long distance transmission for temperature measurement is possible. Actually the bridge circuit are not required for the temperature measurement, which is one of the great advantage, and they are cheaper in cost and the calibration techniques are very easy to be performed. Thermocouples often offer a good reproducibility and the speed of response is high compared to other thermometer. Also the measurement accuracy is also appreciable. So coming about the disadvantages of thermocouple, cold junction and other compensation is essential for the accurate measurements. The second point is they exhibit non-linear curves in EMF versus temperature characteristics. So next disadvantages that we could state is In order to avoid stray signal pickups, the proper separation of extension leads from thermocouple wire is essential. Also, there is a chance for picking up stray voltage for thermocouples. Also, the signals must be amplified in order to get more accurate reading. So, these are the basics of thermocouple. Thank you.